Okay, so now we're to the point where we can actually do some problems that involve sketching graphs of functions. We're going to use what we have, we're going to use our general scheme of exponential functions that we laid out in earlier videos, right? The situation where b could be greater than 1 or between 0 and 1, the b base. And we're also going to add to this mix what we know about transformations of functions that we learned earlier in this course. By transformations, I mean shifting vertically a graph up and down, or horizontally sideways, or possibly scaling or reflecting through an axis. So let's go ahead and start drawing some of these graphs. So use what we know about transformations of functions to graph each function here. And the first one is f of x equals 2 to the x plus 5. And so really, this answer I'm going to base on, I'm going to write this in red. This is like a preliminary picture. I'm going to use what I know about y equals 2 to the x. I know the shape of that exponential graph. It's going to be near the x-axis as a horizontal asymptote. Turn the corner and rise up. It's going to have y-intercept 0, 1. Right? Now that's not my answer here, but that's the basis for my answer. What I need to do is add 5. So I need to shift vertically up by plus 5, right? Up 5 units. And I want to draw a picture of that. So my final graph I'm going to put over here on the side. Here's my x-axis. Here's my y. We don't want to have to plot a lot of points for this. We just want to get the most important characteristics of the graph. One thing that's going to happen is that y-intercept is going to be shifted up 5 units. So if we're already at 1 on the y-axis, we're going to shift up to 5 plus 1, right? Or I'm just going to label it right here and say that's 6. So that's the point 0, 6 on the graph. And I can check that by plugging 0 in for x into this formula. I'll get 2 to the 0 plus 5 is 1 plus 5, or 6. But another aspect of things that we have to kind of just know is that this x-axis, which is the horizontal asymptote, or the horizontal asymptote for y equals 2 to the x, is also going to be shifted up 5 units. So if I shift it up 5 units, I'm going to say about here, I have to draw a dotted line. That's y equals 5. That's actually the new position of the horizontal asymptote. That'll be the horizontal asymptote for this function. So while the graph shifts up 5 units, the horizontal asymptote also has to be shifted up 5 units. And I can draw my graph close to the horizontal asymptote, and then it takes off like so, and so here's f of x equals 2 to the x plus 5, and there's my final graph. I've labeled the y-intercept, I've labeled the horizontal asymptote, and that horizontal asymptote is absolutely essential to understand that picture of the and how it relates to the original 2 to the x graph. Okay, let's try number 2. Now number 2 is 0.25 to the x minus 3. So I'm going to start by thinking about the graph of y equals 0.25 to the x. Now in this first example, number 1, my base was greater than 1. In this example, number 2, my base is between 0 and 1. So I have to use, I'm basing my graph on this general form. So the 0.25 to the x graph actually has that sort of a shape. Does pass through 0, 1, y-intercept. And what I'm going to do now is I'm going to shift vertically down by 3. Right, I'm going to go down 3 units to get my new graph. Draw my x-axis here, y-axis here. So what's going to happen to the y-intercept? It's at 0, 1. I can do, 1 minus 3 is going to take me down to negative 2. Negative 2 will be my new y-intercept. The graph is going to come curving down and turn sideways. I have to also indicate the new position of the horizontal asymptote. Well, it starts off at the x-axis. The horizontal asymptote also is shifted down 3 units. So y equals negative 3. That horizontal line is my new horizontal asymptote. Graph shaped like so. So the y-intercept is really necessary to be plotted here along with the horizontal asymptote. This graph also has an x-intercept. We're not going to worry about that right now. By the end of this chapter, we'll be finding that x-intercept. We're not there yet, but we will soon be there. So we don't have to worry about x-intercepts on these graphs. Okay, number 3. So let me see. 4 minus 10 to the x. Now, do you remember how when we were graphing transformations earlier in the course, we said it's nice to think of this as negative 10 to the x plus 4. If I start out with y equals 10 to the x, that's going to be a graph like so. Base is greater than 1. Y-intercept 0, 1. So we're back to the shape of 2 to the x, sort of. And now I'm going to do this in a couple steps, because the next thing I want to think about is what happens if I put a minus sign outside the 10 to the x. Now here's where we got to remember back to chapter 1. We're actually going to reflect through the x-axis. So this 0, 1 point will reflect to 0, minus 1. This portion just above the x-axis will go just below, and this portion rising up here will now go dropping down below. So we reflect through the x-axis, and then we also got to shift up 4 to get my final graph. So we do a reflection and then a shift upward. If you can do this all at once, it's fine, but I've broken it down into a couple steps. Now when I shift this y-intercept up 4, negative 1 plus 4 will take me to 3. say that's 0, 3. And you can always check by just plugging 0 in for x and seeing what, because it's always easy to plug in 4 y-intercepts. 4 minus 10 to the 0 is 4 minus 1. 4 minus 1 is 3. 0, 3 is my y-intercept. And so the graph is going to go plunging down from the y-intercept. And I have to draw the new position of my horizontal asymptote. The horizontal asymptote stays put for the reflection, but then it's going to be shifted up 4 units. So y equals 4 is the position of my horizontal asymptote, and my graph is going to cut right through where I drew the coordinates for that y-intercept. And the graph is going to look something like so. I need the horizontal asymptote. I need the y-intercept 0, 3. Right now we don't have to worry about the x-intercept. There's my final graph. Now we got a few more we're going to do. I guess I have another page here. Number 4, 3.5 to the x plus 2. I'm going to start out thinking about just y equals 3.5 to the x. Base is greater than 1. So I'm starting with a shape like so. That passes through 0, 1. Here I'm making a change inside the parentheses, inside the exponent. So what's going to happen is we're going to have a horizontal shift. So not vertical, but horizontal, sideways. And we go counter to the sign that we see, right? So I'm going to go to the left in the negative direction by 2 units. So this 0, 1 point is actually going to end up getting shifted to the left. Now, when I shift to the left also, so the y-intercept is going to move. But notice that when I shift sideways horizontally, the horizontal asymptote doesn't change. It's still going to be on the x-axis. It just shifts sideways with everything else, but it ends up in the same spot. That 0, 1 point is now going to be at, you could say, negative 2, 1. And I'm going to have a new y-intercept. I can see what that y-intercept is going to be by plugging 0 into the function. F of 0 is going to be 3.5 to the 0 plus 2, or 3.5 squared. And so that's just going to be slightly higher on the graph, 0, 3.5 squared. And my graph, it's like the horizontal shift isn't going to be so noticeable in a way because the shape of the graph is going to be very similar to what we started out with. So a vertical shift, I think, is much more dramatic for an exponential function, but a horizontal sideways shift, we still kind of, if we don't have coordinates labeled, we might not even notice the difference or the change. Okay. Okay. And okay, number 5, 5 to the minus x. Okay, another variation on things here. If we start out with y equals 5 to the x base is greater than 1. So we start out with a graph that passes through 0, 1. But when we change the input variable to its opposite, remember this kind of transformation is another kind of reflection, but when we change the input to its opposite, we're going to reflect through the y-axis here. So I have to imagine taking this graph, and when I reflect through the y, 0, 1 is just going to stay in the same position. The y-intercept stays the same. This portion rising up here will now rise up that way. This portion, when I reflect through the y-axis, will come down like so. The horizontal asymptote reflects, but it just ends up in the same spot. So here's my new graph, final graph for f of x equals 5 to the negative x power. This looks, it looks kind of like our general form for when the base is between 0 and 1. And that's funny because the base here is greater than 1. We did start out with this shape for 5 to the x. Just I want to make an observation here that, we can think of this function in a different way. 5 to the minus x is equal to 1/5 to the x power, which is the same thing as 0.2 to the x. So this is the same as f of x equals 0.2 to the x. We can actually think of this f of x equals 5 to the minus x as an exponential function with a base between 0 and 1. You could have possibly made this change in the way it's described or written first, and then just drawn this picture. It comes out the same either way. So you don't have to notice that right now. You can just stick with the reflection idea, but it's interesting to see it comes out the same. Okay, and we got one more we want to do here. 10 to the minus x minus 5. Okay, so we're going to start out with 10 to the x I'm thinking about. And now I want to reflect through the y-axis. And I'm just going to make one change first of all. So I'll have this is not my final graph. When I reflect through the y-axis, I get a shape like that. This, you could say, is y equals 10 to the minus x. And now to get my final graph, I have to do a vertical shift. Down 5 units. So when I reflect through the y, the horizontal asymptote doesn't change. When I do a vertical shift, that's when the horizontal asymptote moves. So here's my x-axis, my y. My horizontal asymptote's going to shift down to y equals negative 5. Let's see, this y-intercept was 0, 1. This is still 0, 1. But when I shift down, that y-intercept is going to be at 0, negative 4. The graph is going to rise up that way, flatten out along the horizontal asymptote.